Okay, I will show you two ways of another way of doing these types of questions, okay? You're all on 66, right? Let's go. Calculators ready to go as well? All right. Ready? Ferdinand owns 2 rabbits and would like to build an enclosure adjacent to the house to save on materials. He buys a roll of 50 feet worth of fencing and would like to know the dimensions that would maximize the enclosed area. Okay? We're going to make a change to this question. Or did somebody do this did you do this for homework? Because then you'll be upset with me if I make a change right now. I want this not to be next to something. I want this to be completely open all around. Okay? So we're going to, when it says, would like to build an enclosure adjacent to the house, we're just going to say, we're going to get rid of the adjacent to the house part. Okay? Because that is the video, like the video was next to something. Right? Was it next to something? Did I build the fence next to an existing structure on the video? Yeah. If you're not, you've watched it. Okay. Good. So in this case, there is nothing against, so you can't skip one of the sides. You have to fence in all around. I need you to understand this part. I probably didn't do that on the video, but there is something. If you have a roll of fencing, let's say, and you stretch it out to make that fence, you can do, right? You can make a really skinny, long fence, like enclosure. You could make it a little wider and make it look like this, right? You could make it look like this. But there's a point where you maximize the amount of space that you're enclosing. There's a point where you can get that sweet spot. Just like with profit, there's a way to find the sweet spot. Same with fencing. There's a way to get the maximum area to be enclosed, right? The maximum space inside. And so that's what we're doing here. So in this case, we've got 2 rabbits. And the idea here, I'm just going to tell you, is we're going to build something that's split into 2 equal parts. Okay? We don't want any rabbit to be offended, right? It's like, hey, how come I only got a small space, right? So this is rabbit 1, rabbit 2 gets the enclosure, okay? Now, because we're dealing with area, what you're going to do here is you're going to make an observation that these 2 long sides here, we call them length and length, right? So you need 2 stretches of fencing that goes here and here, and you need 3 pieces of fencing that will cover the width. Okay, so length, and 3 widths. And from that, remember that the area, okay, area is always length times width. Always. Okay, it's this times this. But we can't have 2 different variables. So listen carefully. We're going to write one of them in terms of the other. One of them you write in terms of the other. What does that mean? We use the perimeter. So we're going to say that 2 length, right? These 2 lengths plus 3 widths, right? 3 of these, that has to be spread out and amount to 50. Okay. That is your first step. You use this perimeter here, call that perimeter. We use the 50 and you equate that. Shh, pay attention. This part right here depends on the situation that you're presented with. This isn't going to always be 2L plus 3W. If you made, if you split this into 5 sections, then you'd have 2L plus 5W. Okay? Actually more, 6W because the outsides and the inside. If you build this against an existing structure, okay, then that length, you do not need fencing on that side, so you just have 1L right there. length plus 3W. Okay, so it's always dependent on what is your enclosure like. Do all sides need to be fenced in? Is it just partially, right? And at this point you decide. I always isolate for length. I always isolate for length. So what I do is I go 2 length is equal to 50 minus 3W. Okay. And next thing is to divide both by 2. So length is the same thing as saying 50 minus 3 widths divided by 2. This is extremely important, this one right here. Which one, I don't know if you remember, when you have an equation like this, which one is the independent variable? It's always this one, right? That's in the mix of all the things. This is like your x here. So we can use any values we want. Let me do 10, 20, 30. Sorry. It doesn't matter, by the way. It doesn't matter what you put here. I kind of base it a little bit on how much fencing I have. And it may be that we get a negative out of this deal. It may be. It doesn't matter. So you're saying if the width is 10, what is the length? And you go by this. Okay. So you go 50 minus 3 times 10 divided by 2. And it's a little cramped there. I apologize. And it's important that you make sure that you don't mix things up here. So you go 50 minus 30, you hit enter, and then you divide by 2. So you're with 10 here as well. So if the width is 10, the length has to be 10 as well. Does that make sense? Let's check. If everything is worth 10, do I end up with 50? 10, 10, 10, that's 30 already. And the length is also 10. 40, 50, right? So it does add up to 50 if you have these two dimensions. Let's do it one more time for this one. 50 minus 3 times 20 over 2. I like this one because it's going to give you a negative. 50 minus 3 times 20, that's negative 10. Divide that by 2, you get negative 5. It's not a problem, you'll see. It's weird to have a negative in these situations, but it's fine. It's still going to work for what we're doing. And then the last one is 50 minus 3 times 30 divided by 2. So we go 50 minus 3 times 30 divided by 2. That's negative 20. I would not suggest you should go with negatives, but it still works. And area is going to be 10 times 10. Then it's going to be negative 5 times 20. Then it's going to be negative 20 times 30. You are essentially just coming up with 3 points, folks. 3 points to make up your parabola. The parabola doesn't know that you're working with areas, right? You just need 3 points for you to model the parabola, and then you will take it to the to quadrant number 1. Okay. So 10 times 10 is 100. This would be negative 100. And this is 600. Sorry. 600. Negative. Negative 600. Okay. And now you've created your table. Let's go back. How did this all start? I realized that this was an enclosure type. Make your little sketch. Length is the one that goes across. Widths are the ones that you cut, right? You cut through from one length to the other. Those are called I call them widths. Then I set up, like I literally read this and write it out, and you always make that equal to the amount of fencing that you have. Then I isolate for length, okay, to come up with something like this. Then I let width be whatever I want. You could go 1, 2, 3 if you wanted to, and use this to come up with the length. Now we multiply to get our areas. And now we want the equation that relates the length that goes into L1 and the area. It's important that you know that area is always going to go into L2, always. Whether you put length or width into your calculator, that's dependent on what the question is asking you for. In this case, this is L1, L2. You do not put this width column into your stat edit part, right? So let's come up with our equation here. Stat calc, quadreg and here we go. We're going to go 10, -5, -20. Sorry, what am I doing? What am I doing? There. 10, -5, -20. You should all type this in so that you know what to do with the window, because that's going to be your problem. I type those in. At this point, you remember regression, I go y equals, I clear whatever's in the y's right now. Plot 1 is on, because I want to use zoom 9. Okay, I'm going to go zoom 9. And there it is. You've got something happening here. That'll be the resulting parabola. Let's perform the regression now. Stat calc, quadratic regression. And there it is. Y is equal to -0.67 x squared plus 16.67 x. Now, the window is not good. If you graph it, okay, you see this. I can't have negative. What does x represent? That's my length. I can't have negative length and I cannot have negative area. So I'm going to change my window a little bit. Look up here, right? X min. You just want it to be a little bit into the negatives, not much. Y min. I only want it to be a little bit into the negatives. Okay, so change Y min and X min first and foremost. Hit graph again. And now we're going to chase the curve. Okay, so we want to increase X max. I'm going to go 40. And that actually does it. So once you see it in the first quadrant, now you're in business. Okay. It says, determine the equation that relates the width to the area. We're going to pause this a little bit, put a star on it. We're not going to do this just yet. We're going to stick with this one. D, that's where I want you to focus. This is what most of these questions revolve around. This one right here. What dimensions? It's asking, hey, what length and what width? Right? Those are the dimensions in this case. Would give the maximum area. Okay. So when you think of maximum, what are you thinking of? The vertex, right? Let's go find it. Enter, enter, enter. There it is. Write that down. And this is where I'm going to talk about what I saw on the quiz. Okay, so a lot of you know, okay, keystrokes. You got to put that down. You're really good at writing down the coordinates, so you do this. But then you leave it like that. Oftentimes you just leave it like that. It's a word problem, so you actually need to give me a dimension and the actual units. Okay, so what does this represent right here? The 12.5. It's x, which is, what did I put into my x into L1? Length, right? And this represents area. Okay, this represents area because area went into my L2. So how can I answer the width part? Well, let's do the length first. Length is 12.5 feet. And this is very similar to when we did the profit question. If you have your area, right, just divide it by length. Go area divided by length and you will get your width. So you go 104.17 divided by 12.5. And so my width is 8.33. And so these are the dimensions we're talking about. If the length is 12.5 and every single width is 8.33, you'll maximize the enclosure for those rabbits. They're going to be happy, right? Most space ever. So can we double check and see if this actually works? How many widths do we have here? 3, right? So 3 times 8.33, right? Plus 2 times 12.5, right? That's technically what we're saying here. Oh, we're off by a little bit, but that's because of rounding. It is almost 50, right? We've used up everything in that roll to make our fencing, make our enclosure. So this is how you can check if it actually does work out. Because sometimes students do this, and then if you were to plug it in, you get like 100 or 150. It cannot be, right? So you made a mistake. What is the maximum area, it asks? We already know that. 104.17. What are the units if it's area? Square feet, right? Yeah. So there you have it. Can we graph this? You should be really good at graphing at this point. What do you need to graph? Intercepts and vertex, right? Do the x-intercepts, do I have them? What is one that I know for sure? This is plus 0 here, right? If this is missing, you know for sure that the origin is part of it. So 0, 0 is definitely part of it. Do I know this one out here? I don't. Let's go find it. So graph it. We need to let y2 equal to 0. Second trace 5. Graphing, folks, is the same old, same old. You just need to have that. You just need to have the points. So I found out that it's 25, 0. I do know my vertex, right? The vertex is 12.5, 104.17. So now I have everything I need to make my scale to make this happen. I still didn't see everything that I need when it's a word problem. You would say, in this case, it's length in feet. So some of you were forgetting your unit. You just said time, for example. It has to be seconds. I'll make a slight change in our notes here, okay? Can you look up here? This says comparing width and area. What are we comparing here? Length. So we'll just make that change. And this is area. And what are the units? Square feet. That's just assumed. So I just need to make sure I go as high as 104. And on the X, I need to go to 25. So I think if I go 5, 10, 15, 20, 25, works out perfectly. That's another thing I was looking for scale. Most of you knew exactly what to do when it came to scale. So that's a good thing. How about here? 25s. Go up by 25. That'll do. So I need to go 12.5. That would be right between 10 and 15 right here. And I need to go all the way to 104 right there. And 25 zeros right on the and your equation, which kudos to a lot of you, you knew that that had to be part of it. Okay. Why am I not doing this? Because that's what your calculator does, right? This cannot be, because I cannot have negative area and I cannot have negative length, right? So do not, most word problems. Next year, this will change a little bit. For you in grade 12, we do have functions that keep on going to infinity, but for this scenario, there's no such thing. And what's the domain and range? Domain, just look at, some of you are still having a little bit of difficulty. Just look at your graph, right? Domain, x values. What's the lowest that I see here? It touches right there, so it's 0 all the way to 25. For range, the smallest area I can possibly have is 0, and the largest area would be 104.17. There we go. Okay, I want you to go to 65. That's right before this one. And you have my notes right next to this, okay? I want you to go to 65. And we're not going to graph. We're not going to do any of that. I just want you to come up with the equation right now and find the maximum area, okay? So let's do board work with this one. I'll let you choose your own groups. We have up to 10 groups. If you need more, there's little boards down here. So just to make sure you understand, I need a table, like I need to have the enclosure drawn. I need a table, right? Obviously you're gonna follow this first. Make your table, come up with the equation, and then find the maximum area, okay? Those are gonna be our steps right now. So 65, I will have the key at some point available. So try this.